Have you ever wished you could run another operating system without actually installing it on your computer? That's where virtual machines, or VMs, come in handy. A VM is like a computer inside your computer. It uses your computer's resources, but it acts as a completely separate system. Imagine it as a sandbox where you can play with different operating systems and software without affecting your main computer. Think of it like this. You have a big house. You live in one room, but you have several other rooms available. You can rent out those rooms to guests. Each guest can decorate their room however they like. They can even use different furniture and appliances. In this analogy, your house is like your computer. The room you live in is your main operating system, like Windows or macOS. The other rooms are like virtual machines. You can install different operating systems in each VM, like Linux or even older versions of Windows. Each VM is self-contained, so what happens in one VM won't affect the others or your main operating system. VMs have become increasingly popular in recent years, and for good reason. They offer a wide range of benefits for both individuals and businesses. Whether you're a developer testing software, a gamer wanting to play games designed for different operating systems, or just curious about trying out a new OS, VMs provide a safe and efficient way to do so. One of the biggest advantages of VMs is improved security. Since a VM is isolated from your main system, any malware or viruses that infect the VM won't affect your computer. It's like having a separate quarantine zone for potentially harmful software. VMs are also great for experimentation. Let's say you want to try out a new operating system like Linux, but you're not sure if you'll like it or if it will work well with your hardware. You can easily install Linux in a VM and try it out without risking your main operating system or data. If you don't like it, you can simply delete the VM. No harm, no foul. Another benefit is the ability to run multiple operating systems on a single machine. This is especially useful for developers who need to test their software on different platforms, or for businesses that need to run legacy applications that are incompatible with their current operating system. But how do VMs actually work? The magic lies in a piece of software called a hypervisor. The hypervisor sits between the VM and your computer's hardware, managing and allocating resources like RAM, CPU power, and storage. Think of the hypervisor as a traffic cop, directing traffic and making sure everything runs smoothly. There are two main types of hypervisors, Type 1 and Type 2. Type 1 hypervisors, also known as bare metal hypervisors, run directly on your computer's hardware. They're typically used in enterprise environments for their performance and efficiency. Type 2 hypervisors, on the other hand, run on top of your existing operating system like an application. They're easier to set up and use, making them ideal for home users and small businesses. Setting up a VM is surprisingly easy, especially with user-friendly virtualization software like VirtualBox or VMware Workstation. You first download and install the virtualization software, then create a new VM. You'll need to specify the operating system you want to install in the VM and allocate resources like RAM and storage. Finally, you'll need to install the operating system in the VM just like you would on a physical computer. VMs offer several advanced features that make them even more powerful and versatile. Snapshots, for example, let you create a snapshot of your VM's state at a specific point in time. This allows you to revert to a previous state if something goes wrong or if you want to test something without affecting your VM's current state. Cloning lets you create a copy of an existing VM, which is useful for creating templates or for quickly deploying multiple identical VMs. When allocating resources to your VMs, it's important to strike a balance. You want to give your VMs enough resources to run smoothly, but you don't want to starve your main operating system of resources. It's generally a good idea to start with the minimum requirements for the operating system you're installing in the VM, and then adjust the resources as needed. You should also make sure that virtualization is enabled in your computer's BIOS settings, as this can significantly impact VM performance. And always remember to keep your VMs and virtualization software up to date to ensure optimal security and performance.